Good morning. Today we are going to see the lecture number 24, capacitor start capacitor and motor. Capacitor start, capacitor run, motor. The basic introduction of this topic. This motor, it is one of the type of starting method of single phase induction motor for self starting. For self starting. Second, here the motor having two parts, one is stator, another is rotor. Here the rotor is screw gauge type. Third, it is having the stator, two windings, two windings, one winding for main winding, one winding for main winding, another one for auxiliary winding. This main winding for run position, auxiliary winding for starting position. The other name of auxiliary winding is starting winding. Other name of auxiliary winding is starting winding. Okay, and here there are two value of capacitor is available. Okay, so in the picture, this is one capacitor, this is for another capacitor, one for starting, another for run. Okay, CST or CR. Okay, and these two capacitors, one called at the time of starting, we have to use starting capacitor, the notation is CT. Okay, CT, or we can say it will be C S also. CS. CS stands for starting capacitor, and another for running. Running. This capacitor called as running capacitor. The notation CR. In short form, the starting capacitor we have to say is for start, and this running capacitor the purpose for run. Okay, and this starting capacitor which you have to operate by centrifugal switch. Centrifugal switch is connected in series. In series. But here in running capacitor, centrifugal switch not connected. Okay, this is the basic difference between these two. And one more point, this starting capacitor which should be operate for short time duration, only for short time duration, maybe for 1 second or 2 seconds duration. But the running capacitor we have to operate for continuously, duration, for to make the motor to run continuously. Okay, and this both the capacitor should be connected in parallel. Okay, should be connected in parallel. Sixth point, this both capacitors connected in parallel. Okay, since we are having two capacitor, starting capacitor, running capacitor, so the motor is named as capacitor start, capacitor run, capacitor run motor. Okay, and this motor is also called it as two value capacitor motor. Two value capacitor motor. Okay, two value capacitor motor. Now circuit diagram. Circuit diagram. First we have to give a single phase 230 volt 50 hertz AC supply. Okay, AC supply. This is my terminal points, positive, negative. Okay, this one will be connected in a main winding. Main winding is having just having this is the main winding, which having a combination of resistance and reactance, or M XM, RM and XM. And this main winding should be connected in parallel with auxiliary winding RA, RA, XA, auxiliary winding. Okay. And we are going to take a two capacitors, one capacitor for CR, another capacitor should be CS. This both the capacitors should be in parallel. This both the capacitors should be in parallel, but you have to connect an centrifugal switch. This centrifugal switch, which is the electromechanical switch, which is having a two contact layer, two contacts. The one contact should be connected to the capacitor one end. The another contact should be connected to your auxiliary winding. Asha, door mat close. This is centrifugal switch. Okay, this one is centrifugal switch. And inside to your machine, there will be a rotor structure. This is the rotor. This rotor, which is having a slots, almost 36 slots or 25 slots. Since it is a screw cage rotor, in screw cage the rotor bars are short circuited with the end rings, but in slip rings slip rings are short circuited with the brushes in series arrangement with the external resistance. Since the single phase induction motor, it's having only the screw cage rotor. Which is the screw cage rotor. So here the value of capacitor, because we know a basic principle, the capacitor is a passive element which stores energy in the electric field, as well as this capacitor is applicable for leading power factor. Why? Because it is leading power factor means we know that the reactance term in terms of impedance Z equal to R plus JXL minus JXC. This plus symbol for lagging, minus B for leading it. It is having a leading power factor. This XC equal to 1 by omega C, where omega equal to 2 pi F. This X is the reactance term. X is the reactance term. Now, the rating, okay, at the, because this CS stands for starting, the CS stands for running. Okay, this starting capacitor we have to operate only for a short time period. Okay, it is only to operate for short time period, but the CL capacitor we have to operate for continuously to run the motor for long time period. This both the capacitors are made up of an electrolytic type material. Electrolytic type material. Since there will be a large number of currents are flowing, so we have to maintain the reactance term in both the capacitors simultaneously. Okay, both the capacitors simultaneously. The capacitor reactance which is applicable in a starting capacitor, that is the reactance term which is applicable here in starting capacitor, it is very much less. But in running capacitor, the X term should be high. It should be high. Okay. Please note down. In starting capacitor, the X stands for reactance. This is for reactance. The reactance which is less. But here it should be high. The reason we have to limit a current. If reactance term is very much lesser, then only we can improve and starting current, as well as we should improve a starting torque. Not improve, we should limit. We should limit the starting current. Limit the starting current. Okay, so we have to limit it. The starting current we have to limit it by using this capacitive reactance. That's what the reactance term available in starting capacitor, it is less. We have to limit it. Okay, and the operation. The operation which is very much simple. If you give the supply, the centrifugal switch closed, then the starting capacitor CS gets charged, okay, by using an auxiliary winding. So the current flows here through this auxiliary winding. The current flows through this auxiliary winding. So the motor will start run for short time. Once the motor reaches ns synchronous speed, then you have to open the centrifugal switch. Okay, this point will be closed, then you have to open the centrifugal switch. Once it will be open, then immediately this starting capacitor will be disconnected, okay, which will be disconnected from auxiliary winding. It will be disconnected. So therefore the motor should run continuously. Okay, Once it is disconnected, okay, the circuit it will be like this. RA, XA, RM, XM, this is the rotor. These are the slots are there. Only one capacitor. That is nothing but CR. This is main winding. This is starting winding or auxiliary winding. Here P, N, single phase AC supply. So the current flows here, it is IM. The current flows here, it is IA. Okay, so this is for running purpose. The motor is run continuously. Okay, so once the motor starts running it, you see the phasor diagram. This IM, this IA auxiliary winding, which will be leading it. Okay, which will be leading it, and this is nothing but IM main winding. The angle between this IA to IM phi, it should be 90 degree. So the IA leads voltage by 90 degree. Okay, by 90 degree, and IM lags voltage by 90 degree. Okay, the overall angle is 90, but half of the portion it comes around the 45 degree. Okay, we'll get 90 degree. Okay, this is 45, this is 45 degree. Okay, why it is leading? IA it is leading means since capacitor is there, that's what it is leading. Okay, here main winding there is no capacitor, so it is lagging it. Are you understand? This is my junction. Are you understand? This is phasor diagram. Then when you come to the torque, speed, characteristics. Okay, torque speed characteristics. You can see the torque speed characteristics. This is the torque speed characteristics of the motor. Here x-axis torque, y-axis speed. Okay, the first step we are operating by using both the capacitor, it will be start reaching torque value is somewhat high low, and it will be increasing it. Then it will be reach ns, synchronous speed. Now once it reaches synchronous speed, immediately we have to open the switch, that is n0. During that time again the torque value somewhat less, and it will be increasing slightly. Okay, then it will be reach synchronous speed. During that time there is we are operating only one capacitor. Okay, only one. This is torque speed characteristics. The main application here, this type of motor is quick and smooth running. They have higher efficiency, and they are used for loads of for higher inertia, frequent starts when pull-out torque and efficiency required are higher. These motors are used in pumping equipment, refrigeration, air conditioners, ceiling fans, blowers, etc. And this is a pictorial representation of ceiling fans. Here, line and neutral. This line will be connected to the SPST, single pole single through switch. Then it is connected to the capacitor, ranges 2.5 to 3.5 microamperes. This is ceiling fan. The ceiling fan arrangement is having the light also. To control the light we have a dimmer. Dimmer is a methodology to control the light luminescence as well as the intensity value. Okay, now to control the speed of the fan we need a regulator also. Okay, here there are two capacitors are there, one capacitor for start, one capacitor for run. Now when you switch on it, immediately the capacitor start running. When you switch on during position, the current flows. This is my integration for capacitor. Capacitor is a property which stores energy in the electric field, lower limit, upper limit. So this lower limit will be 0, this is 230. Okay, so when the capacitor will be starts moving from 0 to 230, based upon this voltage, the speed of the fan will be reach 1500 rpm, that is ns. Once it reach 1500, the centrifugal switch connected to the motor, inside the motor it will be automatically cut off. Okay, which is automatically cut off, and which will be connected with the operate the another capacitor to make the fan to continuously running. Okay, this is for ceiling fans. Thank you.